easy because when you're working with absolute value, you're going to have two triangular regions, okay? Now, if you don't prefer the geometric approach, okay, we can actually rewrite this as a piecewise defined function. We have two separate lines, okay? So let's look at this in a different way. Okay, you actually have a line segment, is probably a better way to say it, okay? This left branch of the absolute value could be represented with a linear equation. Okay, tell me about that line. It has a y-intercept of
3
and a slope of 1. Okay, so we are working then with integrating, I'll start with y equals, we can go to f of x. What was my linear equation?
x plus negative x.
Negative x plus 3. Okay, but that's actually a function that we're not integrating from negative infinity to positive infinity. This is only the region from what to what?
Negative 2
Negative 2 to
3.
3. Okay? And then we can add on to that, okay, we have the other line, this other line segment over here can also be represented with a linear equation. Anybody know what that equation would be?
X minus 3.
X minus 3, and we're integrating, or looking at the area from what to what in this case? 3 to 4. Okay, with respect to x. Should get the same answer, by the way.
Is it dx or f of x?
Oh, it's dx. Okay, so now you're just using your definite integral rules. Let's just prove that we get the same answer. Okay, let's integrate negative x plus 3. What would the result be? Negative 1/2 x squared plus 3x, and we would integrate from negative 2 to 3. Right. And the definite integral of x minus 3 would be 1/2 x squared minus 3x, and we'll integrate from 3 to 4. See if you get the same values. Go ahead. Pop in the upper limit and then subtract the result of the lower limit. Should still get 13 as an answer. Did you get 13? Which method do you prefer at this point?
The other one.
Other one.
Geometric.
Geometric, yeah.
That thing. It's just what it's called.
Well, for my, I don't, I can choose whichever one I want. I don't think. Okay, so hopefully you all got 13. Okay, but I want you to go back and see, because the actual, if you didn't have the visual, coming up with the two linear equations and how it's related to absolute value is a pretty straightforward idea. Okay, so when you're working with the absolute value of x minus 3, okay, it's going to actually come out to the following piecewise defined function, which means two separate functions. It would end up being the opposite of x minus 3 for values of x that are less than 3. And it would end up just simply being the given inside of the absolute value, x minus 3 for values of x greater than 3. Okay, so it's the opposite in one direction and it's given in the other direction. Okay, so you wouldn't have to have the visual to actually do that. So let me test and see if you really understand what I just said. Let me make up one for you. Absolute value of x minus 2 would split into what two functions? Opposite of x minus 2 for values of x less than 2, and then x minus 2 for values of x greater than 2.
Where do you get
Pardon?
Where do you get the 2?
Because you're always going to have a vertex.
Oh, okay.
Okay, you're going to have a value of 0 there. Okay? So it's kind of a choice. Okay. Any questions? Did everybody get 13 for your other Okay, let's look at 6. Woo-hoo. Okay. Again, in some cases you can take a geometric approach. In some cases, you can use a definite integral. Okay, but before we even take the geometric approach with number 6, I want you to see if you can integrate it with u substitution.
Substitution.
Huh?
Did you say something about substitution?
You would have to integrate with u substitution here because you have an expression raised to a power.
Oh.
I don't think it worked.
Wait, check the weather.
You're waiting.
Never mind.
No, we need to go outside to search for the legendary
He said
flying
you're
pig of
right.
Borneo.
What did he just say?
Hey,
I have no idea.
Oh, wait, I get that.
What about check the weather?
Why are we checking?
Remember my joke from a while ago, check the weather and how it must be snowing?
When you get a double variable.
Reference, it was a reference to that.
Got it.
Multivariable. I was referring back to Hunter last time toward the
Yeah, I
end of the
got that. I
bus.
don't understand how we use substitution if there's no x.
I was actually a compliment.
Okay, I'm simply saying, okay, let's go
You're
back to
never
what we
wrong,
would do
there's a
in the
shock.
past, okay? I would get rid of the radical, this would be 16 minus x squared to the what power?
1/2.
Okay, so if we would want to integrate that, if you have an expression raised to a power, you have to go back to u substitution. It shouldn't work, that's what you should run into.
Yeah.
Okay?
Yeah.
Alright, so
Okay.
you
We're all on
said
that.
u equal to 16 minus x squared, what is your du? 2x dx, okay, what's the problem, why does it work?
There's no x.
Okay, you got this extra variable that you can't have, okay? So that means that you have to take the geometric approach, okay?
Oh.
So my point is, in some cases, you can approach it non-geometrically, but in other cases, you're forced to use the geometric approach. Okay, so let's
Just use
look
the
at this
geometric
algebra
approach
wise,
every
okay?
time.
We've got this function, y equals the square root of 16 minus x squared. Okay, you should all have some sort of a sense of what sort of conic section this is, and whether it's the top half, bottom half, right half, or left half. Top half of a what?
Circle.
Circle, okay, it's the top half because you have a positive square root. Okay, now, you might not need to go through the algebraic process to graph the top half of your circle, okay, but I'm gonna go ahead and go through it. How do we undo this radical? We do what to both sides? Square. So we have y squared equals 16 minus x squared. Get x squared and y squared on the same side. Okay, so this would be a circle with a center at the origin with a radius of what?
4.
Radius of 4, okay? We're only going to look at the area of this top half of the circle from -4 to 0. I'll shade that in a moment. Okay, so as best you can, sketch the top half of the circle with a radius of 4. Centered at the origin. Okay? Now, we're only looking at area under the curve from what to what? What's your lower limit?
-4.
2, 0. Okay, so really you're working with 1/4 of a circle here. I have a yellow pen. I'm using it.
I really can't see
Okay,
that.
so that's the area that you're trying to find. Any ideas?
Yes.
Good, what's your idea?
Find the whole circle and then divide that.
Okay, so we're working with 1/4 of a circle, so the area that we are dealing with is 1/4 of a circle. Area for circle is what formula?
Pi r squared.
Pi r squared. Okay, so in this case, what's our radius?
4.
But we're only working with 1/4 of it, okay?
Yes.
4 squared is 16, divided by 4 is
4 pi.
4 pi. Exact answer, do not multiply by 3.14.
1592653.
Okay,
Okay, we don't.
good.
That's it?
That's it.
We can't do that. That's it.
Expecting more.
Pardon me?
Source.
No. Okay,
Oh, really?
so let's go on. Okay, let's go to number 7, shall we?
Oh, beautiful. Yes. Good job.
Stupid.
I love that.
Okay, so for this problem, okay, you can give it a shot if you want to with your substitution, but you'll run into the same idea. You'll have an extra variable, so you cannot approach this with a definite interval. So you would have to use the geometric approach. Okay, so you're gonna want to sketch it out. Okay, but just go back to your algebra skills. So let's start with y equals 4 plus the square root of 9 minus the quantity x plus 2 squared. Okay, so that's the equation that we're working with. So
No.
hopefully you know at this point if we have a top half, bottom half, or right half, or left half. What do we got? Top. Okay, so what are we gonna do first? Okay, before you actually we're solving a radical equation. Before you square anything, we need to move this constant to the other side. What operation moves the 4 to the other side?
Subtractions.
Subtraction. So we have y minus 4 equals the square root of 9 minus the quantity x plus 2 squared. What will be your next step? Square both sides. To undo a square root, you square both sides, okay? But we're gonna take this quantity y minus 4, okay? You gotta take the whole quantity and square that. And then we have 9 minus the quantity x plus 2 squared. We just get what's underneath the radical. Okay, there is no need to multiply all this out because you would really want it in simplified form. So now what?
Put the x plus 2 squared on the other side of the
Move the
equation.
quantity x plus 2 squared to the other side.
And then
Okay, so we
divide
have
that.
the quantity x plus 2 squared plus the quantity y minus 4 squared is equal to 9. Okay, hopefully you recall your general equations of circles. You've got x minus h squared plus y minus k squared is equal to r squared. We worked on this last year. Okay, that's a circle, but it's just not centered at the origin. Okay, what's the center of this circle?
-2, 4,
-2, +4, what's the radius? 3. Okay? We'll get back to the definite interval idea in a moment. Okay, so we're looking at